applied controls as an automation specialist with a focus in Siemens industrial automation and low voltage drives. Juliet Sardian, also seen sharing her camera, is also another presenter, and she is also an automation specialist with applied controls. Stephen Arnold, our product manager, is also a certified Siemens automation specialist as well. As you can see on the screen, this webinar will include a coverage of the S7-1500 advanced controllers. I'm going to do a presentation. It's going to last about 15 to 20 minutes, and then Juliet will be doing a live product demo afterwards. You can all see my PowerPoint here, correct?
Yes.
Awesome. Okay, that being said, we'll get started. So if you don't know a lot about Applied Controls, we are a local employee-owned high-tech automation distributor and solutions provider. We educate and support local manufacturers in implementing emerging technologies to reduce costs, increase productivity, and improve safety. Our offerings range from industrial computers and software, robotics, machine vision, and motion control. For those of you that do not know, we have a full-fledged support staff that covers each one of those main product focuses. With that being said, let's hop into the presentation. Like I said, we're going to be speaking about the advanced controllers, the SIMATIC S7-1500s. So getting started here. If you look at the overall SIMATIC controller portfolio, obviously the SIMATIC S7-1500 falls into the advanced controller area. There's two major areas, advanced and basic controllers. All the PLCs in the advanced controller area are based on the SIMATIC S7-1500. Whether it be a software controller, a distributed controller, or the SIMATIC S7-1500, as mentioned before, these have the unique features seen on the right side of the screen. Those being efficient engineering, innovative design, reliable diagnostics, safety integrated, security integrated, and technology integrated. That is something that all of these controllers from basic to advanced all share within this group. They are all engineered within TI Portal, and they are all scalable. That is one of the major selling points of these controllers. The advanced controllers are used with applications that require higher memory, high-speed applications, many communication connections. If you have an application that has a complex automation architecture that has a lot of HMIs, drives, and other field devices, is probably going to be best suited for the S7-1500 as opposed to the S7-1200 compact controller. And these are the major industries like automotive, aerospace, railways, and so forth. Obviously, the industries I showed you on the previous slide are not all the applicable ones. The S7-1500 is used across the board. It doesn't have to be a complex application with tons of HMIs to drive and drives. It can be used in a standalone application as well. It is all dependent on your situation, really. As you can see, we have good business in these industries as well. You can see here all of the industries. And it's not exclusive to these either, obviously. So as you can see, there's lots of different applications that this S7-1500 can be used for. And as we go further in the presentation, you'll see how that's possible. That being said, let me run through a real quick summary of the features included in the S7-1500 CPU. First of all, security integrated, very important. Cybersecurity is a critical topic nowadays, and the S7-1500 has a lot of security integrated with the CPU. Now, obviously with Siemens, propose the defense in-depth strategy for security, which involves firewalls, locking your doors, things like this, ensuring that no one can get in the back end. We also have a maximum security on the PLC itself for integrated copy protection and know-how protection, improved protection against manipulation and cyber threats. It is all built with inside these PLCs, and it's really state-of-the-art technology. Also, the efficient engineering, obviously. We support all of the IEC 61131-3 programming languages. We also allow the integration of high-level languages like C and C++ on our multifunctional platform CPU, the MFP CPU. So you can also integrate this together with the standard PLC application, aka the control program. There's a technology integrated version, which will allow us to do advanced motion control on all these PLCs. Let me clarify that one more time. All of the S7-1500s have a level of motion control, which I'll talk about. But there is a specific technology CPU in the S7-1500 line that can do advanced motion control as well. These functions include absolute gearing, camming, and kinematics. Safety integrated, obviously, that's integrated with the S7-1500, like I mentioned on the last slide. And it can be used in one application, one network, to do both standard and fail-safe communication. It's a huge advantage in savings in hardware, considering you can do it all in one device. It's a very high performance controller as well. The backplane speed is incredibly fast, and we have a Profinet with deterministic time response and the precision area of microseconds if you need it. Also, the diagnostics is a huge selling point for the S7-1500. The automatic generation of system and user diagnostics allows fast troubleshooting. The system diagnostics are completely built into these CPUs. So when you design your hardware configuration with your CPU, I/O, and everything else, the system diagnostics are already set up. If you have a wire break, which we'll show you in the demo later, or a card disconnect, you automatically get that feedback on your HMI and on your PLC's display. It's a really good diagnostic system and a huge selling point for these controllers. I should also mention that the S7-1500 now supports an active backplane bus that allows increased system availability due to reaction-free plugging and unplugging of I/O modules during operation. If one or more of the I/O modules are replaced, the system will remain in run to not stop your control program. The S7-1500 is also a very innovative design. Like I mentioned before, it has the display on the front of the CPU. As for some of you that don't know, the S7-1200 does not. This supports a lot of things, but to name a couple of features, it supports diagnostics and the initial commissioning and service like tag status, IP address assignment, backing up the control program. There's a lot you can do right from the display of the CPU. And also, when you talk about diagnostics, it's also very good as far as the LEDs on the CPU and the modules associated. The ET200 MP style modules, which you can see here kind of in this area. There's also a lot of convenient wiring due to pre-wiring position of the I/O modules. Juliet will show you that in the demo a little bit later. Jumper links, extra room on the cards for cable trays for wires. There's a lot of nice benefits built into the hardware of these PLCs. Okay, on this slide, I am showing some additional innovative system functions that give more productivity. On the top, again, you see cybersecurity, which I already mentioned. Integrated safety in the middle. Again, that is a really huge and unique selling point. Also on the bottom, we have predictive maintenance and digital services through MindSphere. So we actually have a connection from the PLC to MindSphere as well, so you can do those predictive maintenance and digital services if you decided to use it. A few more features and benefits to mention on this slide. Simplified maintenance. We can also do process diagnostics with these PLCs. Process diagnostics is that you can purchase so that you can keep a better eye on certain processes and diagnostics within your system. It makes it very easy to troubleshoot your system. It pulls your ladder logic right up on your HMI so that you can see and identify your problem and get back up and running quicker. We also have an integrated trace feature that is very unique. You don't have to sit on a separate computer connected to the PLC to use the integrated trace. It is all built into the PLC. You set it all up within the PLC, and we're going to show you this in a little bit too. It's actually a common trace editor together with drives, multiple PLCs. It's really nice. It does the advanced mathematics as well, and it gives you the ability to troubleshoot really. In addition to the Profinet built on board on these controllers, we also have Profibus as a function of these controllers as well. And all of these controllers have OPC UA built in. There's no additional hardware. There's just a license fee you need to pay to use OPC UA on these CPUs. Like I mentioned in the beginning of the presentation, there's a lot of special modules available. As you can see on the screen here, we have the standard base CPUs, the safety rated CPUs. There are redundant CPUs, technology CPUs for advanced motion control, the MFP, which allows you to integrate those higher level languages like I mentioned, compact CPUs that have I/O modules built into the rack of the PLC already. And there are also Cyplus Extreme versions of all of these PLCs, which essentially conformally coats the devices. And I'm going to break down each one of these individually now. So first of all, the compact controllers. We have two different compact controllers in the S7-1500 line. the 1511C and the 1512C. The big advantage of these CPUs is that they not only have built-in I/O on board, but they also have technology integrated. So you can see they actually have integrated counting measurement, frequency measurement with fast inputs. The outputs have the ability to use PTO, pulse train output, and pulse width modulation that is all built on board. Also, if you look at the I/O cards that are attached to these units, they are fixed and not removable. They're actually thinner. They're 25 millimeters in width, and they're the push-in type modules, so you can actually push your wire in instead of screwing them down. If you need the functionality in these PLCs, it's a big money savings to actually buy it as a compact controller, and it saves a lot of space. As I mentioned before, we have a high-level technology CPU that does higher level motion control than the standard CPUs. Now, what does that actually mean? Well, we have several CPUs that do extended motion controls like absolute gearing, camming, and kinematics. This functionality is all built in and is also available in a fail-safe variant. As I already just mentioned on the last slide, the SM1500 does motion control on board, but you can see from the chart on this page what you get in addition when you get a S7-1500T technology CPU. When you start getting into coordination, synchronous operations, cams, SCAR robots, delta pickers, etc., that is when you would move from a 1500 to a 1500T. That is the extra functionality you get with the 1500T. And there's a nice little graphic here that kind of displays what those functions are. So you have the S7-1200, which is capable of speed set points, basic positioning. The S7-1500, which can go and get up into some minor coordination, but when you really want to get into advanced motion control, that's when you use the 1500T to get those kinematic functions, absolute gearing, and camming. One of the unique controllers we have in the 1500 line is the SIMATIC multifunctional platform, the MFP Controller. The cool thing about this is that it integrates the high-level languages C and C++ together with the standard PLC. So within the standard PLC hardware and format, you have a standard PLC, and you've got the ability to run a separate scan time running C and C++ applications. And this is great for somebody that has an existing code in C++ or has a complex algorithm that they want to run, or a gateway they want to run this application. You can run it right in C++ or C, and the communication goes back and forth between that and the controller and the control program. And this is also available in failsafe, like I mentioned. This can also be used to connect to MATLAB and Simulink for modeling. We also have a version of the SM1500 that is a kind of hot backup system. It's the SM1500 redundant system, and you can see in the picture of the middle of the screen. Basically, it's two CPUs watching all of your I/O. So if you had 1 drop or 100 drops or 1,000 drops of I/O in the field over Profinet, both CPUs would be connected to all of that I/O. One CPU is acting as the primary CPU, actually doing the control, and the second is acting as the backup. So if the primary shuts down or fails, the other will take over automatically without a blip in the control system. So this could be used for applications for maybe Navy ships, for cruise ships, for tunnels, anything that you don't want to shut down really. Things like maybe like an airline baggage conveyor as well, which we'll actually talk about a little bit more on this next page. You can see some extended use cases here for the redundant controllers. The SM1500 R and H redundant systems are used in applications shown on the screen, like I just said. Airport logistics like bagging, transport, and storage. Tunnels with ventilation, smoke extraction, light traffic control. HVAC and data centers with ventilation, air treatment, and heating. These are the type of applications that cannot shut down and must always be continuously running. So you must update a CPU, or you have a failure. You do not want these processes to stop. It's worth a lot of time and money, and it's worth paying a little extra for the CPU to ensure, in worst case scenarios, if a controller dies, that you will have a controller on backup ready to take over that control program. I mentioned before that we have a special Cyplus Extreme for harsh environments. This isn't just for the controllers as well. This also applies to Siemens I/O drives and some other devices as well. If you look at the chart here, you'll see that the standard CPUs are in the temperature range of 0 to 60 degrees Celsius. When you convert this to a Cyplus Extreme, which means is what they do is literally upgrade the components to a different temperature ranges and conformally coat the board so that it can handle condensation and humidity. You'll see that doing so increases the temperature range of the CPU to -40 degrees Celsius to 70 degrees Celsius. Also, due to the conformal coating, you can operate these in chemically active substances as well. You can see on the table, sand, salt, mist, the growth of mold, etc. Those can all be seen listed here, really. So any of our products, including these controllers, can be made into a Cyplus Extreme version. It's not limited to these controllers once more. So now we kind of have a breakdown of all the different controllers, and I'm going to break them down really. Just focus on this chart for a minute. If we look at the interface line right here, that tells you how many interfaces are on board the CPU. The green boxes represent Profinet interfaces, and the purple boxes represent Profibus connections. The 1s and 2s stands for separate IP addresses. So you can see that it varies as you go from the 1511 with one IP address with a switch port all the way up to a 1518 with 4 different addresses, including a Profibus connection. As you increase from the smallest to the largest CPU, you can also see the increase in work memory, data bit performance. Essentially, everything kind of increases as you go up from the 1511 to the 1518. As you can see here, also listed are the technology, MFP, and the redundant/high availability CPUs. Like I said, the interfaces here you can see as you go up, you have more interfaces, more work memory, more data memory, faster bit performance, etc. To give an idea in terms of pricing, what the difference would be from a 1511, say, or this 1511 doesn't matter, up to a 1518. A 1511 usually ranges at about $1,100, whereas a 1518 MFP CPU can go up to like 12 grand, if not more. So you can see that there's a large array of different PLCs and prices for those PLCs. So fortunately, there's not just one really expensive PLC, otherwise you wouldn't be able to buy it. That being said, like I just mentioned, the 1511 usually ranges at $1,100. There is a SIMATIC S7-1500 starter kit that comes with the 1511, as well as a 365-day for step 7, or not trial, but a 365-day license for step 7 professional V16. And for those of you that do not know, this is the licensing that is required to program S7-1500s into the IA portal. You can see here that in addition to the PLC and the 365-day license that it comes with, a memory card, licensing for ProDiag for up to 250 supervisors, and as well as a OPCUA license as well, and then the power supply and Ethernet cable. So, you know, typically if you were to buy all these individually, that would probably cost in the $2,500 range, but you can get it for $1,100 now if you would like to. And obviously, we can answer questions regarding this technology if you are interested. That being said, Juliet is going to be taking over now for the actual product demo.
All right, thank you, Corey, and good morning, everyone. My name is Juliet Sarden, and I'm also an automation specialist here at Applied Controls. Before we get into the demo portion, I just wanted to let everybody know that if you do have any questions, feel free to chime in at any time. We also have the conversation in this chat, the chat area where you can just type in questions at any point. Greg did ask a question about accessories for the mounting rail. He said, are there accessories for the mounting rail 160 millimeters to mount the standard DIN rail?
I don't believe so.
Okay.
But I can double check, Greg. I'm almost positive that you need to use the special DIN rail that comes with the S7-1500s, but I will double check.
Awesome. All right, so if anyone has questions moving forward during the demo portion, please feel free to put that in the chat, and then Corey, I'll just ask if you can keep an eye out on that.
Totally.
Awesome, thank you. Great. So as Corey mentioned, we'll now be transitioning into the demo portion of the webinar. So I'll start with a brief recap of the hardware, and then I'll show you guys more on the web server capabilities that just allow you to access the PLC straight from a web browser. So I'm going to direct my webcam over to the demo, and we'll get started. So it might be a bit hard to see the display screen in detail, but I'll show you a little PowerPoint slide on that in a bit. All right.
I will pin your screen. Spotlight.
Can you, Corey, can you see the demo okay?
Yes. Yep, and I just spotlighted your cam, so everybody should be able to see it in their main window.
Perfect. All right, thank you. Okay, so let's get started. So for this demo, what we have here is a power supply, a PLC, and 2 I/O cards, as well as a wire break push button here on the side, which I'll use to demonstrate the diagnostic features that we have built in to our PLCs. So starting on the left here, we have a standard power supply in the form factor of an S7-1500. All it does is convert 120 volts to 24 volts, and then there's a wire underneath here that connects directly to the PLC right here underneath. And then the PLC powers everything else from via the backplane. So we also offer power modules that just click directly onto the backplane on either side of the PLC. So for example, let's say I want to add additional I/O cards to the system, and this power supply isn't enough to power everything up. We have power modules that you can attach onto the backplane for that purpose. So the PLC that we're using here is, it includes a 1515 CPU with 2 Profinet ports underneath here. I'm attached to one of them with my laptop currently. And it also includes a 4 megabit memory card, which is inserted down here at the bottom. It also includes a very high resolution display that you see here. And this display is really convenient because it just provides a lot of information right here at the PLC. So again, I'm going to show you guys a PowerPoint slide in a bit to show you guys what kind of display screens we have, but we have a lot of information ranging from overview IP addresses, diagnostic information. You have settings that you can access here for the PLC, module information, and display information. So all of that is right here at the CPU, at the PLC. And what's great about these 1500s is that let's say for whatever reason your display screen gets damaged, whether it gets cracked or the backlight goes out, whatever the problem is, and you need to replace this display screen, you can do so just by popping it out, and it's really just that simple. And all you would need to do is just replace this part, and the PLC is still running. You don't have to worry about downtime. Once you get your replacement part, you just pop it right back in, and the display screen will just reboot on its own. You don't have to worry about any programming or anything like that. And the biggest thing is you don't have to worry about downtime. So for other PLCs, you normally, if that were the case and you need to change, swap out your display screen, you would have to change the entire PLC, but this is not the case with our 1500s. So as you can see, everything comes right back up once it's rebooted, and you have all your information right here at the screen. So let's see. We also have the stop and run buttons down here on the PLC, and your LED lights here for additional information. You might be familiar with other versions of our PLCs where the run and stop usually looks like a switch here. In this case, they're in a button format, and once you close this lid, it's covered up. So you don't have to worry about accidentally turning your PLC into stop mode. One thing that I do want to point out too, just so you guys are aware, if you aren't already, all of our devices have a QR code on them. So if you need, specific information, or let's say you want to replace a part and you want that information, right away on your phone, just scan the QR code and it'll give you all the information you need for that specific part. So even for this display piece, you have information on this specific part on the back end. So just something to note, we also have a industry online support app for iPhone and Android phones, and you can download that, and it just gives you quick and easy information on all of Siemens hardware. So just something to note. It's a convenient thing to have. So to the right of the PLC, we have two I/O cards. The first here is a digital input card with 16 inputs, and then we have a digital output card with 16 outputs. So you'll notice that the digital input card has what we call a standard terminal block, and then the digital output card has what we call the top connect terminal block. So this top connect terminal block is just a pre-assembled option that Siemens offers, and it's basically there to help you save wiring time and minimize possible sources of error. So all it is all the wires are pre-wired, and you would just wire up the ends of these to whatever you need to wire up to. And the another thing to note is we have what's called a pre-wiring position with these terminal blocks. So if I take this out and kind of pull it up in this fashion and click it back in, it's basically now sitting in what's called the pre-wiring position, and it disconnects your terminal block from power, but it just allows you to access these terminals more easily, and it's just a matter of making your process a little easier. Now we also have what's called coding elements on these terminal blocks. So let's say I'm wiring everything in, and then I go to put these terminal blocks back into the cards. I won't be able to place the I/O terminal block into the output card. It won't allow me to do so. So little features like that just allow you to minimize error along the way and allow you to kind of go through this wiring process a lot quicker. So one thing that I do want to show also is that let's say you're wiring everything up quickly, and I put this terminal block in and it establishes connection, but I don't necessarily click it back in all the way. Once I close this door, it'll force that back in, and you won't have to worry about any loose terminal blocks or anything like that. So really minor details, but at the end of the day, it does save you overall time, downtime, wiring time, minimizing error, all of that. So I'm going to show you a little bit more about the built-in diagnostic features with this push button here, but first I want to introduce you guys to the web server, and then we'll come back to show you all the built-in diagnostics. So I'm gonna pull up a slide really quickly before I open up the web server. Let's see. Let me know, Corey, when you can see my my screen. Sorry, it's kind of taking a while to load.
Okay.
Can you see my screen all right?
Yes.
Okay, so just a brief overview, just in case you can see the screen on the physical hardware. There's a bit of a glare that I see on my end. You have a bunch of different display screens on these CPUs. You have overview information. You can have all your CPU information, IP address, diagnostics and alarms, which is really convenient to have. You don't have to necessarily, plug a computer up and open up Portal to get all that information. You have it right here at the display screen. You can set IP addresses, change security settings, view, modify watch tables for diagnostic purposes, update firmware, backup programs, etc. So all of that can be done directly at the PLC with that display screen. Now for the web server, let's say you're not at the PLC and you want to access the PLC information, diagnostics, etc. You can access all of that from the PLC's web server, whether that's via intranet or internet. And the web server is included with all 1500 CPUs, but it's not specific to just the 1500s. It's also a functionality that we have available for our S7-1200s and our ET200 controllers as well. So to activate this web server, what you would do is you would basically set everything up in the hardware configuration of your PLC within Portal. And if you just go to your properties of the PLC, you'll see this web server option here, and you'll have all these different settings you can set up. You can set up different user accounts also. So let's say I only want to give someone minimal access, I can do that as well. So to access the web server itself, let me change my sharing settings. Let's see. All right, so Corey, can you see the web page all right?
Yes.
Awesome. Okay. So to access the web server, you'd simply type the IP address in of your PLC in the web server, and it'll bring you up to a start page. Right now I'm already logged in, so you see all of the options that I have access to because I have full access. But if I were to just type in the IP address, you'd be brought to a start page, and you would just type in the username and password for whatever access level you want to access. So I'm going to go through a couple of the features. I'm not going to go into extreme detail on most of them, but it's just to show you what's offered on the web server so that you guys are, aware. So at the start page, I can run and stop my PLC straight from the server. So let's see. You guys should still be able. Actually, Corey, can you still see the demo in addition to the?
Right now we can only see the web server.
Got it. Okay.
Well, actually, we can see your screen, but it's just really small. Let me try to spotlight it. Okay. Yeah, you should be able to see it now.
Awesome. Okay. So, and you can still see the web server, right? Clearly.
It's either or. You either have the small screen or whatever spotlight is going to take over the main screen. So.
Oh, got it. Okay. No, that's fine. Take it back to the web server.
Okay.
Thank you. All right. So you guys will just have to trust me that when I place the PLC into stop mode, you'll see on the physical hardware that it's indeed in stop mode. So I'm going to turn it back to run mode. Let's say I have a bunch of PLCs on the line. And I want to make sure, I'm looking at the right one. I can flash the LEDs right here and, check to see on the PLC that this is indeed the one I'm looking at. You have a lot of diagnostics information right here on the web server. So I can get hardware and firmware information. I can look at program protection. Memory is a convenient one to have too. I can look at how much load memory is in use. Runtime information is also a convenient function we have here. All of the current information on program and communication load and cycle time can be found in this tab here. And it basically just enables you to see whether there may be any runtime problems during the execution of your user program. So all of this is live. Good information to have at your fingertips if you need it. Again, I can also I can print this information out as well, right from the web server. I'm not using a fail-safe device, but if I were, I'd have information on that as well as far as diagnostics. We have a diagnostics buffer here also. Again, all of these functionalities that you see here on the side, this is all configured within TIA Portal. So you can pick and choose what it is that you want to be able to access and see. So what I'm going to do now is I'm going to push that wire break button that I introduced earlier on, and that's basically just going to simulate a wire break in the system. So what you'll notice is I'll see a new event popping up here. It's going to give me all the details at the bottom here. It's going to tell me errors on which IO card I can find this error at. And in addition to having all that information on the web server, I also have that directly on my PLC. So I'm going to stop sharing just for a moment so you can go back to the PLC and see that all of that, again, this is all built-in diagnostics, so you don't have to do any programming on your side of things for this feature. This is all built in. I have a wire break that's simulated. I see that error on the PLC, on the I/O card, and directly at the I/O at which this error is occurring. And again, I have that on the web server as well. So you have many different places where you can get this diagnostics information from, and so that you can, you know, troubleshoot a bit quicker. So I'm gonna release that push button, and that wire break has now been corrected. So you would also see that wire break information under alarm. So I'm going to push that button again. You'll see it pop up here. There it is. I can click on it and get more information down at the bottom. I release that push button and it's gone. Now, let's say you're using motion control blocks within your program as well. You would have the ability to see motion control diagnostics from your web server as well. We'll come back to this a little bit later on in the demo. Corey will talk a little bit about this. Module information as well. You can look at all the different modules you have on the line. This is just a simple demo, but let's say you have, you know, many devices and modules out on the line. You can use the web servers to look at all of that information at once. Alarms. You have communication information as well. You can you can look at different port information, Profinet port or interface information. You can look at statistics, connection status, connection resources. Let's say, you know, I have a bunch of connections out on the line. This will tell me what my maximum is, how many I have left. I can look at topology, tag status. So let's say you want to monitor any tag values that you might not already have in your watch table. You can do so from here. I can access my watch table. I can have multiple ones. Again, this is all configured within the project. And I have full access, so I can modify these values straight from the web server if I wanted to. The watch tables page is, it's often used for, again, the watch tables are also available directly on the PLC display as well. And they're often used for diagnostic purposes. So the tags that you see here, again, have already been configured in the hardware configuration, and depending on whether or not you have access, you can change these tag values right from you know, your web browser. You can perform online backups as well. You can create an online backup, or you can restore a PLC right from a web browser. The trace function, this is another powerful diagnostic tool. Let's say for someone that wants to troubleshoot remotely, user can access and configure this function again within the PLC hardware configuration and portal. And this is a function that's supported by all of the CPUs within the S7-1500 line, but it's also a function available for the S7-1200s and the ET200 controllers as well. I'm going to open up a short video on this, and Corey's going to take over and just describe the trace functionality and tie that back into the motion control diagnostics as well. So, Corey, whenever you're ready, you should be able to see the video, right? You can see it.
Yeah. Can you make it full screen?
Yes.
Thank you. All right. So what you're about to see here, more or less, is a video that's going to show how you can access the trace through the web server. The traces are always set up prior to, meaning that you have to configure what you're going to be tracing, and then you would have to upload that trace to the PLC to make it accessible from the web server or from the screen itself. So at some point, when Juliet gets down to the user-defined pages, there is the ability to basically create your own HTML web page. And on that web page, Juliet, can you show that real quick?
Yeah.
Actually, I think he might show it, does he?
He's going to get down to it, yeah.
Okay, that's fine. We can just do that then. More or less, like I said, you define the parameters of the trace. either in Portal or usually in Portal, and then you would download it to the PLC so that it is available through the web server. And when he goes to the trace or the HTML page, which should happen in a couple of moments, you'll see that they basically created a web page to control a motor, more or less. And it should be pulled up in a second. So what you see here is a switch to turn on, to enable the drive, more or less. And then there is a sliding bar, which you'll see right below that. And as he turns on the drive here and then sets the set point, you'll see the set point bar increase, and then you'll see the drive actually ramp up. Now, this is linked in the PLC to a technology object. And for those of you that do not know what a technology object is, it's more or less a software object in the controller that represents mechanical components. So what they're doing right now is tying together the HTML page to basically command the technology object. And then on the trace page, they're displaying those parameters that are being used on the HTML page as well. So you see, in this case, when the drive is prompted to run, that is the trigger to start the trace, and then it'll actually graphically display the set point and the drive actually ramping up to reach that set point. So yeah, I think you can hop out of this one, Juliet.
Yeah.
Because in our specific demo that we were supplied, the trace was not set up for some reason, and you can see that if we were to expand it. But either way, if we go back over to motion control diagnostics, you'll see the HTML was controlling this speed access technology object, and then the trace was just representing it graphically. And you'll see that when you do have a technology object configured in the PLC and you set access to it on the web page, you have access to all the status of the access itself, of the actual motion, and then it'll display any errors or warnings as well, which is helpful if you're just watching this over a web page and you need to maintain or ensure that your technology objects are working as expected, and therefore your actual mechanical components.
Right. And then you have motion status information as well, and service view information. So let's see. In addition to the motion control diagnostics and the trace functions, you also have data logging information that you can set up user files. Let's say you want to put the manual up for your devices on here for an operator to access, or for someone to access via the web server. You can place those files here. Again, you have the ability to create user-defined web pages, as Corey mentioned. Just allows you to create custom pages that you can view and manipulate data. And file browsing capabilities as well. And that's pretty much it as far as all of the functionalities we have available on the web server. So I'm trying to think if there's any. I think we touched up on pretty much everything that we have available on the server. And I'm going to pull up one more slide. Corey mentioned earlier the starter kit. We have those the S7-1500 starter kit available as well. So just to remind you guys. And unless, Corey, you have anything else to add?
There's a couple of questions, Juliet, that I'm going to address quickly.
Yeah.
So we'll start with Greg. Greg asked, hey, Corey, are there any supporting documentation wiring diagrams for TI portal example configurations to configure a 1513R redundant controllers with a Siemens CFU? So, Greg, we personally have not dealt with the CFU at all because Applied Controls just recently got approval from Siemens to actually deal with PCS. But that being said, the CFU would be, once it's configured, would just be another Profinet device on the network. So your redundant controllers are sitting at the top more or less, and then downstream you'd have all your devices. The CFU would be one of those devices. I can see, I'd have to do some more research on the CFU to see what the functionality would be, having a PLC speaking to a CFU outside of the redundant nature of the PLCs, because like I said, it's just another Profinet device in the network. So if one PLC dropped out, the other PLC would pick it up and would continue running regardless. I can't speak to the configuration of the CFU, like I said, because we've never dealt with it. That being said,
Someone asked for the part number of the starter kit as well.
yes, Thomas, if you could email us, we'll gladly help you take care of that. I don't have the part number off the top of my head, but Marie may. Youngbo Chen, for a sensor wire breaking, does it detect any of the wire break, like power grounding signal wire, for example, a proximity sensor? There are 3 wires normally. If any one of these wires is broken, does PLC be able to detect it? It would detect it would be checking the power circuit for whatever sensor you're dealing with. So if common or power dropped, that's when you'd see a wire break. Greg also asked, what's the default password to log on the web server? If you don't have anything set up, Greg, then I think what you're seeing here in that picture you sent is all you have access to, and you don't need to log into it. You would have to set up user management and then define accessible levels for that user management that you had just created. And then for each level, you can define what they have access to. But I think in your case, since you don't have anything set up, you only have access to the start page and the introduction.
Yes.
I'm just trying to figure out H-Sync forwarding with the CFU since it's supported for that. Thanks to Startic is awesome. Thanks for helping us sell that. OPCOA and ProDiag. Could you explain what this is / does? OPCUA is Open Platform Communication, and now the UA stands for Unified Architecture, meaning it's a means of connecting several devices of any nature, really, to a single platform. And for the Siemens controller specifically, the S7-1500 can act as a OPCOA server or client. The S7-1200 can only act as a server. Server meaning it can read and write information, and the client being only able to read information from said server. And like we said earlier, OPCOA functionality for the S7 controllers, SM1500 and SM1200 controllers are licensed technically. And just to clarify this for anyone that does end up trying to purchase a license, you don't actually need to download anything. They just give you a certificate, and it's associated with your name in the license, so then it gives you access to using it. So there's really nothing you need to download. You can have the certificate in your back pocket just to verify that you do own it, or you do have the privilege to using that license, more or less. ProDiag is something that is separately licensed as well. More or less, Tyler, ProDiag is something you can use. Say you had a PLC and an HMI, which is usually a typical configuration in most cases for automation. You can actually display portions of your code on the HMI in the case that there is a fault or a warning or an error. And it'll display specifically where in your code it's seeing that error or fault. That is more or less in a nutshell what ProDiag is. It's a means of increased maintenance, and that's kind of it in a nutshell. And when it says 250 supervisors, if you'd like to talk about that separately, I'd be happy to explain it, but I don't want to go into too much depth here. Like Marie just said, Thomas will get you the part number after for the starter kit. Greg, I will do some research into into specifically dealing with the CFU, since I'm curious. However, like I said, we haven't really ever dealt with the CFU before, so I'd need to look into that some more. However, I hope that I was able to answer your questions to some level of depth and detail. Sounds good if I have some time here, if I want to log in some time. Yeah, well, we'll do some research into it. I'll have to talk to Stephen as well, like I said, or my boss, Juliet's boss, and the product specialist group's manager.